Getting more from the Elastic Block Store, speed and IOPS. I love this slide. It's just so meaty. So much information in one place. Standard disclaimer. This information will change. It's not an if, it's a will. Probably already has changed. So go to the Amazon website, type in EBS volume types, and you'll get an updated view of this. Probably most often thing that changes is the pricing. So 3 types of storage. Let's start on the right-hand side with EBS Magnetic. Now the storage of yesteryear that you can use for your instances running in Amazon Web Services. Isn't it weird to be thinking that hard drives, you know, the platters, the heads, you know, your computer's been booting off these things for years. Amazon is now saying, yeah, that's good for infrequent data access. Man, kick the sleeping dog on the floor. It's like, oh, magnetic drives are junk. That's, oh man, I would not say that. When I think of infrequent data access, I think of S3. You know, chuck it in a bucket somewhere, or Glacier, it's an archive, that kind of thing. So I'm thinking if you've got user storage, you've got files, flat files, AVI files, download files, you know, those kind of things. Oh man, use EBS Magnetic all day, get the crazy cool costs. The big thing that is going to kill you with magnetic storage is the IOPS. What is IOPS? IOPS stands for input-output operations per second. Essentially, no longer are people really concerned about how much throughput. I mean, take a look. Throughput is 800 megabytes per second. Now, when I think in terms of network, because I'm a network guy, you actually multiply that by 8 to get the network speed. What is 0064? So that'd be 6.4 gigabits per second network speed. That's amazing. That's really good speed in terms of that, but that's not people's concerns anymore, because usually you don't have these long sequential reads. I mean, you're not copying a 1 terabyte file from one server to another server very often. If you do, then great. That's where that speed will come into play, and you'll get some crazy cool fast speed. What we really care about now is the IOPS, meaning you've got these instances or servers that are accessing their hard drive a whole bunch with a bunch of little read-write files. You know, when somebody's on a web page, they click a link. Click, oh, right to the hard drive. They navigate to something else. They start watching it, a little click, 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 little accesses of this. So essentially, it's not the drive. So here's your little hard drive, right, with your little needle on there. It's not the drive itself and how much data it can actually send. It's how fast can that thing move around and find that data. That's the IOPS, and that's the killer of machines nowadays, or instances that are booting. And you can see, compared to solid-state disks, magnetic is brutally slow. So anymore, Amazon is recommending solid-state disks for your instances to boot off. Notice, first thing it's saying for the general purpose solid-state disk is boot volumes. And the thing that works really well for that is the burstable IOPS. So whenever you see burst next to the IOPS, they're essentially saying, yeah, you got 3,000 IOPS sometimes. If you don't use it for a while, you get your 3,000 IOPS because it's a burstable, which is awesome, because when you boot up an instance, what's it going to do? Whole bunch of read and write. It's booting the operating system of Windows or Linux or whatever operating system you're actually running. It's booting it up, doing a whole bunch. You're getting booted really fast, and then by the time the operating system's booted, Amazon's tapering you down, meaning their provisioning's kicking and being like, well, you can't get that 3,000 IOPS all the time because, you know what? Number one, people pay for that, and number two, you're going to start competing with the other instances that are running on there, because everybody, you know, would be doing a whole bunch of IOPS on there. So you get the burst, which gives you a short-term boost of IOPS, and then it's just back down to the general IOPS. Now, what are the general IOPS? Whatever. It's kind of like whatever's available. You're competing with everybody else, maybe a lot, maybe a few. However, the solid-state disks are now recommended for your normal computing. Now, if you have some intensive machines, especially, you can see right here the two things they're talking about: databases or input-output intensive operation application servers. That's where you want to use the provisioned IOPS, and that's where you pay Amazon to make sure that you are guaranteed those IOPS all the time. So outside of just buying more provisioned IOPS, paying more money, is there anything that I can do to get faster performance? Yes, there is. I'm glad you asked. First off, hitting the high points, standard EBS volumes, you can see magnetic storage, 40 to 200 IOPS, solid-state storage, just like I mentioned, burstable up to 3,000 IOPS, and that's it. Otherwise, if you are wanting beyond that, you're going for provisioned IOPS, unless you do a strategy like this. This strategy has been around for a while with Amazon Web Services, and people need to know about it. RAID 0 multiple standard IOPS volumes. When you get into provisioned IOPS, your pricing goes up quick. So what you can do instead is use a bunch of standard IOPS volumes. Why? Because essentially your provision server, your instance, is sitting up here, right? And it's connecting across the network to all these different storage devices, right? These are your EBS storage. So we'll just call it EBS storage 1, EBS storage 2, EBS storage 3. So when you provision yourself, whether you be using magnetic storage, whether you are using magnetic storage or using solid state disk, you're going to get essentially one of these. So let's just say I provision a 50 gigabyte EBS volume to attach to my instance, right? What's going to happen is they're going to go to one of these EBS data stores. Let's just say it's a solid state disk. It's this standard one right here. And it's going to carve out, it's going to say, here's 50 gigabytes for you, my friend. All yours. Or what you could do is I could go onto my instance and I could provision 5 10 gigabyte volumes. What happens then? Well, each one of those volumes is treated independently, meaning you're getting your own little set of IOPS that are guaranteed for you for those volumes, whether it be a burstable or just, kind of going into 40 to 200. So you get 5 of these 10 gig. You know where I'm going with this, right? And you RAID them together. What is RAID? RAID stands for, what is it? Redundant array of inexpensive disks or something. Yeah, that's it, right? So now, so Google, and this you can actually use RAID 0. The reason I'm stumbling on that is I'm like, what? It's not redundant if you're using RAID 0, although I think R stands for redundant. So what you do is you actually use those 5 10 gigabyte disks and stripe it. It's called a stripe set. That's what RAID 0 is, to where you read and write data to and from those disks all at the same time. So instead of, let's just say I've got a 5 gigabyte file, right? Instead of saying, okay, write, sending it to that solid state, one disk getting hit, your provisioning's kicking in. It's like, oh, you can't use that many. So all that. Or you can actually take that one 5 gigabyte file and split it. It's actually going to split it probably into 64K chunks. But at the same time, here's the concept. You're going to put 1 gigabyte of each of that file on each one of these disks, striped across. 5 drives writing at the same time. 5 drives reading at the same time, if you're reading that data off, or whatever the case is. So technically speaking, you could get 5 times the performance, 5 times the IOPS, 5 times the throughput by doing that. Now, is there any drawback to it? You're like, wow, you just showed me how to work the system with Amazon. No, actually, this is even in Amazon documentation. If you dig enough, you'll find this recommendation because it for them kind of spreads the landscape as well. Instead of having to support one customer, and that could really hammer that one device, that customer spreads their load over multiple EBS volumes, and they're like, yeah, that's cool, we're cool with that. And so you can get better performance. Now, the one thing to remember is this does increase your failure landscape. Meaning, if any one of these EBS volumes goes down, where's my purple pen? Die. If that one goes down, you lose everything. The whole 50 gigabyte volume is gone. So obviously backups are huge, but EBS is so solid, meaning it's got such a low failure rate, 0.1% a year as the low part. I think 0.4 is the high point between that on a failure rate. It's kind of like, it's pretty safe. Always keep your backups. I'm not saying don't keep backups. I'm just saying this is a great way to improve your performance. Last thing that you can do is go for the EBS optimized instances. Now, what is this? Well, going back to the picture I just drew, your instance is connected to a network that reaches its EBS data store over a network environment. Now, anytime you introduce a network into it, you introduce the potential for a bottleneck, right? Because your instance is sitting there running along with all these other hundreds of instances running inside of Amazon Web Services, could potentially be accessing the same data store, but most likely is definitely using the same network fabric to communicate. So what you may be running into is not necessarily a bottleneck with the EBS data store, which your monitoring may detect. You might be running into a bottleneck with the network, thus the EBS optimized instances. Matter of fact, I just looked at it, and this is now changed. Everything changes all the time. Speeds from 500 to 2,000 megabits per second, or 2 gigabits per second, based on the kind of instance that you're actually provisioning in there. And what essentially that says is, you know what, I'm going to dedicate, let me just say it from Amazon perspective, I'm going to guarantee that you are going to get this throughput between your instance and your EBS data store 99.9% of the time. So if you want one of these EBS optimized instances, it's not a certain instance type that you choose, it's just a checkbox. Check this out. I'm going to take you to EC2 land, hit the running instances, and let's spin up a new virtual machine. I'll hit launch instance. Now, the operating system you choose doesn't matter. The kind of instance that you choose does. So I'm going to go with, let's do a M3 extra large. You'll see that when I go to the instance details, I have this wonderful little checkbox right here for EBS optimized instance. Launch this as EBS optimized instance. There's no value to type in. I want this much megabits per second guaranteed. And the reason for that is based on the instance type that you choose. You can see right here going down this list. You have a guaranteed value that Amazon has chosen for you. No, you don't have to pick. We'll choose that for you, my friend, based on the kind that you choose. So there is an additional cost for the EBS optimization, but based on the machine that you're running. And you can, I mean, notice here, do you see small in the list? Do you see micro? Do you see medium? No, these are for the beefy machines that you're saying, I want them even beefier. That's where the EBS optimization comes into play, right? So you now know, from going through this nugget, how to optimize the performance of EBS volumes, both from choosing the certain kind of volume, whether it be magnetic SSD or provisioned SSD, over to the ways of optimizing it. Some of them is just giving more money, like the EBS Optimize or buying the provisioned IOPS, or you can start using the ninja-like strategy of splicing together small little SSD volumes or magnetic volumes in a RAID 0 set, spliced together in your operating system to really get a lot of throughput that you wouldn't otherwise get at the cost, let me back up, at the same cost as you would if you would have just purchased a single volume locked in at a certain level of IOPS. I hope this has been informative for you, and I'd like to thank you for viewing.